Okay, so today we're doing topic 4. We're going to introduce two very, very commonly used Python libraries. We're going to use this throughout the entire course, Numpy and Pandas. Before getting into this notebook, I wanted to talk about how the next couple of topics are structured. So I think because we have one more study group on Sunday, I think it kind of spaces it out a little bit nicer. So topics 4, 5, and 6 are actually very interconnected in the sense that for the project at the end of the phase, if you stop at topic 6, you can pretty much finish out the project. Not to say that 7, 8, 9, 10 is not important, but the focus is going to be on 4, 5, 6 actually. So just some good info to know. Today we're going to introduce NumPy. It's actually going to be more Pandas than NumPy, but Pandas takes some concepts from NumPy that are going to be useful. So we're going to talk about that today. Topic 5 is all Pandas. And you can see there's a lot of stuff here, all different Pandas functionality that these labs just walk you through. And then topic 6, there's visualization. And visualization actually is incorporated into topics 4 and 5 because there are many different ways to do visualizations. I'll talk more about it when we get to visualizations, but as an overview, for visualizations, you can do them with different libraries. And we're actually going to talk about this next week. Matplotlib is a library that does visualizations. Seaborn is another one. But on top of that, within Pandas, you can also do visualizations. And so within Pandas here, I think topic 4, there's a couple, there's a lab that says you can do visualizations with Pandas. Why I bring this up is you can really pick and choose which kind of library or which kind of method you want to do visualizations with. Fun fact, Pandas visualizations actually draw from the Matplotlib library. Seaborn also draws from the Matplotlib library. So they're kind of connected. Pros and cons. Pros is they're interconnected, so they're quite similar in the way that the visualizations look and the way that they're used. Downsides is even though they're all drawing from the same library, to plot the same graph, it's 3 different syntaxes to plot the same graph. So that's why I think it's more important to, I don't know, either get used to all of the nuances between the different ones. I personally, when I was learning, I just stuck with one method and stuck with that all the way. Some people just, in some scenarios, it's easier to use one over the other. So just over the next few topics, when you see different visualization techniques, just know that it's never consistent. I think visualizations is something that's also come up in the 101s the most, just because it's one of it's one of the harder things to remember how to do. I will admit, every time I need to plot a more complicated visualization than anything that isn't a straight up histogram, I have to look it up just because there's so many different methods of visualizations going on in my head. So very, very normal especially for visualizations, that you have to keep looking stuff up. Why I mentioned that as well is in topics 4 and 5, and I actually did talk about that very briefly here. For topics 4 and 5, there's actually a mini project for each of them. And I would like to discuss either one, not this week's 101, but next week's after we get to visualizations and all that. So the following week's 101s. Each of these has a mini project. So you can see here, topic 4, there's a mini project here. And then topic 5, there's a mini project here as well. Both of these projects include having to do visualizations. So I do think it might be a better idea to work through everything aside from the mini projects first, get to topic 6, and then go back and then work on the mini projects, just so you'll have all the information and you can create the graphs that you want to create, rather than I don't know, playing with all different kinds of visualization techniques and then getting confused between all of them. But I mean, it's up to you how you end up doing them eventually. So the mini projects do take up a good bit of time. I would say it's it's a few hours of work for each. So they're both kind of similar. I would say this one is going to be a little bit more relevant, the one for topic 5. But if you want more practice and if you have the time, do both. So yeah, that's just some context on what's coming up. I think that the way that we have our schedule set out, we actually have a longer amount of time between topics 6 and 7. I think, yeah, because we moved one of them to Sunday. And by the way, we can all see the calendar now, hopefully. So yeah, 6 will be on Tuesday, and then we have like a full week until we go on to topic 7. So with that gap, I think it's a good amount of time to, let everything from topics 1 through 6 sink in. Because topics 7, 8, 9, 10, yes, they're important, but they're a little bit more, what's the word? They're less important for this project, and these are things that we'll come back to in more detail later on anyways. Cool. Any questions about the stuff that's coming up before we dive into material for today?
Would you suggest doing the topics before the study group or after?
The way I have it structured, just because for most of my students in the past, is that my study groups are kind of like foundational, but also more focused on like, I don't know, it's like you don't need to have gone through the study group, the lab material in order to understand my study groups. And the material that I've created is just in that way, because in the past, most of my students haven't been able to get through all the labs before study group. So you don't have to have done that. I do think it is beneficial, just because if you're like working through your labs and then you see that, maybe something isn't really sticking, or because as you'll see here, there are like a couple different things that I'm focusing on that aren't like big parts of the labs, it might resonate a little bit more. So I don't know, I've kind of created these to be more flexible, that they can kind of fit in regardless of whether you've gone through lessons or not. I will say I don't think it matters too much whether you get through the lessons before or after study groups.
Got it. Thank you.
You're welcome. Anything else?
Yeah, I just to go back, you said we should do topic 6 before we do the mini projects. Is that correct to say?
That's my recommendation. Yeah, you don't have to do that. I just think that because in each of these mini projects, you'll be asked to do visualizations. And at this point, the amount of exposure you have to visualizations is less. So I do think it's a better idea to, get a little bit more practice with doing visualizations before going back to doing the mini projects.
All right, thank you.
Yeah, I'll make that more clear in the homeroom. Anything else? Awesome. Well, let's dive into new material. A lot of this text is taken from the lesson, so I won't go through word for word. But basically today we're going to go through 2 of the most commonly used Python libraries in data science. Numpy, which stands for numerical Python, and then Pandas. So Numpy is actually used for more like mathematical operations. So you can see here, let me zoom in a little bit, actually. There we go. Lots of useful functionality for math operations on like vectors and matrices. Vectors and matrices is something that we'll come back to in phase 3. So we'll actually see a lot of this stuff again and in more detail. And then matrix computation. Don't worry about this for now. Why Numpy is extremely useful is there is a data type known as Numpy Arrays. And so we're going to get into more details onto like why Numpy Arrays are so powerful and why they're so important for us. Numpy Arrays look a lot like lists, but it's a lot more efficient. And again, later I'll talk more about that. The other library that we're going to be using is Pandas. So Pandas is a package that's designed to work with relational data and replicates the functionality of relational databases. This whole idea of relational data is basically, if you can have anything in a table format, that's relational data. I think that the terminology here is a little bit less important unless you want to get into a database field. But basically, if you see anything that's like a table format, it's actually a relational database. Pandas is really good for data wrangling. As you can see, you can do a lot of data cleaning and like manipulation, aggregation, visualization. Oops. We'll get to this in more detail, but within pandas, we're going to talk about two main data structures, or data types. So whereas in NumPy, we had the arrays. So NumPy arrays is a data structure or a data type. In pandas, there are two main data structures and data types, series and then data frames. And then we'll talk about that in a little bit as well. And with these data types, you can do a bunch of different things. And we'll talk about all of these later on. So that's like a quick overview of like, what are the main uses of NumPy and pandas. Okay, so we're going to talk about NumPy first. And the main thing I'm going to talk about with NumPy is the main strength that NumPy has over Python lists, because actually NumPy arrays look very much like Python lists. Before I get into that, whenever you want to use any sort of Python package, you got to import it. And with importing, you can see here that for NumPy, we always do import NumPy as NP. It's just so that every time we type or use something out of the NumPy library, we don't have to type the full 5 letters of NumPy. We can just write NP. And that's actually an industry standard. I don't know who decided to shorten it to NP or not anything else, but that's just how it's done. So import NumPy as NP is the typical way you import NumPy. And actually something pretty interesting is you don't have to, I mean, it is industry standard to call it NP, but you can import it as anything you want. If I want to import NumPy, if you want to be like really chaotic and like import NumPy as like, I don't know, PY, which is a bad idea because PY is short for Python. I can actually, instead of NP here, use different letters, and that will also work, but don't do that. Just letting you know that that's how import statements work. So this will import NumPy. And so every time you use the letters NP, it knows to take out of NumPy. Actually, we'll come back to this, but the exact same thing happens with pandas. This is another industry standard import statement. Always import pandas as PD. Again, I don't know why they decided on PD, but that's just the typical way to import pandas. So instead of typing, I guess, the 6 letters of pandas, you can just use PD. And that just means that you're using something out of the pandas library. Cool. All right, so the main thing with NumPy, as I mentioned, like for now that we're going to use is NumPy arrays. And NumPy arrays are more, they look very, very similar to lists. So let me just run this for itself first. Let me change everything back. Okay. All right. So here I've made a NumPy array. And the way that you create a NumPy array is you start with a Python list object, actually. So as you can see here, we have this list of 1, 2, 3, 4. So actually, let me just do this. Print 1, 2, 3, 4. Or actually, let's try something different. List equals 1, 2, 3, 4. We're gonna print list. Oh, you should not use list because it's a keyword. And then we'll also print the type of list. And then we can turn this into the array. Okay, we have more to go off here. All right, so what I did here is first I have this Python list, and you can see it prints here, and it is, the type is a list. And then to turn something into an array, I just have to coerce it into an array. And basically that just means I'm parsing it, I'm putting it through this array object. So I just have to do NumPy array, turn that list into an array. And that's what I'm doing here. And then the list just becomes an array. So now here's a NumPy array. I'm printing out this statement here, this variable here, sorry. And then I know it's a NumPy array because the type of it is numpy.ndArray. And so they look very, very similar, but they just have different functionality. Any list method that we had from before, like .append, .extend, what were some others? .sum, those are some like built-in list methods. They won't work on NumPy arrays. I mean, some of them overlap actually, but the methods that you use on arrays are different from the methods that you use on lists. Again, there's also a page of like all of the list, all of the array methods somewhere on the internet. The really, really useful thing about arrays is that it supports this functionality known as broadcasting. And broadcasting is what makes a NumPy array much more powerful than a list. It's this idea of it's able to do broadcasting. These are just some examples of arrays. As you can see here, some very, very useful methods that you might want to use is here you can see that we'll get into like more specifically what vectors, matrices, and tensors are much later. But for now, just know that these are lists and some nested lists. Here you can see that I'm printing the array followed by the array dot shape. So the dot shape is an attribute of any NumPy array that shows the dimensions of the array. So here you can see here I have this NumPy array of 1, 2, 3, 4, 5, 6. And the shape, which is very, very similar to length, is 6. So it has a length of 6. Here I have like a nested array, right? Here you can see I have a nested list for matrix 1. I have 1, 2, 3 in one list, 4, 5, 6 in another list, and they're both in one giant list. Because we put into a NumPy array, it sees it as a two-dimensional object, which is pretty neat. And so therefore, the shape of this is 2, 3. It becomes 2 sets of 3. And you find that out through doing like the dot shape. And same for all of these. You can go as many dimensions as you want. Like here you can see I have like this super nested, like 1, 2, 3, 4, 5, 6, 7, 8. I have like two groups of 2. Is that right? Yeah. So I have 2 groups of pairs in one single list. And so that's just the dimensions. And so dot shape is going to be something that's pretty useful. More so when we get to phase 3, because in phase 3, we're going to talk a little bit about like linear algebra and how that's good for machine learning. But don't worry about it now. Some other similarities first is that you can index an array the same way you index a list. So let's say in this vector, here is 1, 2, 3, 4, 5, 6, right? And what do I name it? Vector. The way that you index a vector, same way you index a list. So let's just say I want to get the second one, that's 3, fourth one, that's 5. Exactly the same way. When it comes to a matrix, which is, matrix 1, I think is what I called it. If I want to get the first element, same thing, but this gives me 1, 2, 3. If I want to get a specific element within this 1, 2, 3, I can index it again. And so let's say I want to get the number 3, I will put 2. So depending on how nested an array is, you can index it that many times. So just as a final example with this tensor, which as you can see, there's like nested. You can do tensor 1. I can add on, all right, let's say I want to get like the 5, 6. That would be 0. And let's say I just want to get like the number 6. I just grab the 1. And so don't worry about like these really nested lists yet. We're going to get into that later. But just to show you all, this is the functionality. And this is actually the same if you had just like regular nested lists. It doesn't necessarily have to be arrays. Okay. So back to broadcasting, which was what we talked about that makes arrays better than lists. So broadcasting happens when you perform operations across arrays that has a different number of dimensions. By different number of dimensions, I mean by like a vector is a one-dimensional thing and a matrix is a two-dimensional thing. And so broadcasting happens when you're trying to do operations between both of these. As a quick example, before I get into explaining what's happening, let's say I just have this scalar number. If anyone has like seen, if anyone remembers like physics, is this what you talk? I don't remember. But let's just say like we have this number 4, and then we had this vector of 1, 2, 3, 4, 5, 6. In NumPy, I can do vector plus scalar. And as you see, vector was 1, 2, 3, 4, 5, 6. If when I do vector plus scalar, it raises every element in the vector by 4. So by doing vector plus scalar, even though vector is like a list technically, and then scalar is just like one single number, the plus 4 is broadcasted to every element in the array. So that's the idea of broadcasting. in more like technical explanation, NumPy basically makes the duplicate of the lower dimension array as long as the higher dimension array contains the same shape in order to execute the operation. We'll see what I mean here when I have this like other example down here. But basically the idea is why this is more powerful than a list is if I wanted to get from 1, 2, 3, 4, 5, 6 to 5, 6, 7, 8, 9, 10, as you saw yesterday, we can do this in a couple different ways, right? We can loop through the list and append like number plus 4 to a new list. We can do it as a list comprehension. We can do it as like with a lambda as well. The thing is when you do it as a list, you're doing it one at a time. We're doing it one element at a time. We're updating and adding 4 to one element of the list at a time. Whereas in an array, they're actually doing it all at the same time. So it's actually just much faster to do this kind of thing in an array. If you just know that you are going to do the same action to every element in an array, just by doing this so much faster. Of course, you know, with our Python example, we're using such short lists, but when you're working with data that's like millions of rows long, or I think even the thousands, you already can like visually see and feel the difference in the time it takes to do an operation like that. So that's what's really powerful about NumPy arrays, the fact that it can do broadcasting. So let's just take a look at like a slightly higher dimension thing. So I have this vector of 1, 0, 1, and I have this matrix of 1, 2, 3, 4, 5, 6. Actually, let me print these out first. Let's print V1 and print M1. So cool. Let me actually print this. If you ever need to print a new line, you use the escape N. So it kind of splits it up there. Anyways. All right, so we have this 1, 0, 1. And let's just say I want to broadcast this 1, 0, 1 onto this. Will it work or not? So let's just try. Let's just see whether, let's say we just want to add 1, 0, 1 to everything. Let's do M1 plus V1. So what happens here is it says we get an error that operands could not be broadcast together with shapes 3, 2, and 3. Visually, why does this happen is because each of these nested things are of length 2. And this one list is of length 3. And it doesn't really know how to add 1, 0, 1 to each of these smaller elements. So that's what I mean here by like, it contains the same shape in order to execute the operation, right? You can't force a length 3 something onto a length 2 something and do some sort of operation there. It just doesn't know what to do. Also, it doesn't really know to like, I don't know, flip the 1, 0, 1, because you could say, all right, what if I add like 1, 0, 1 like that? That's also not how it works. You have to look at which contains what shape. What would work, however, is if I edit this matrix a little bit to look like this. 1, 2, 3, 4, 5, 6. So now instead of, you know, I sort of like flipped the shape of the matrix such that it's 3 across, 2 down. Now you can see that this matrix also contains like length 3. So with this, I can now broadcast my vector onto the matrix. Of course, we're not going to be dealing with such small little numbers like this, but it's just good to know broadcasting. Most of the time, the broadcasting that you're going to be doing is this kind of broadcasting. You usually just want to do like one simple operation onto, you know, a bigger data type. And we'll talk about that, I think, tomorrow when we get into Pandas too. So yeah, that's one of the most powerful things about arrays. Questions about this? All right. So something for you to play around with. We have tensor2 over here. Where is tensor2? Okay, let's just go with our tensor. Okay. So we have our tensor here. What kind of shapes can be broadcast onto this tensor? Feel free to put notes here if you like, but basically if I have this tensor, I can add np.array. So I feel like if you have this notebook and if you want to like practice with this and mess around with this, play around with like making arrays of like what can be broadcasted, what cannot be. Let's say I have, I don't know, will this work? That'll also work. Add 1 to everything. So yeah, very unlikely. Even like later on, we don't necessarily play with tensors. Tensors are basically like 3-dimensional objects that have like nested. So we don't play with this often. Mhm.
How common is that in like data science to see like, I guess 3D? I'm not sure about 4D, but like 3D and like higher
Yeah.
like dimensions.
We actually get into it in phase 4.
Okay.
Images are 3D objects actually, and they're
Okay.
all represented as arrays. It's actually pretty neat. In any image, if you imagine, like, let's say you have like, it goes by pixels, right? So let's say you have like a 128 by 128 image. It's basically like a grid of 28 by 28 of one, did I say 20 or whatever, that dimension, number of pixels. And then every pixel is represented by a number. If I had a black and white image, the number just represents the intensity of like the gray scale in an image, which is super neat. Where it becomes a tensor is, you know how images have RGB? You will have one grid of red intensity, one grid of green intensity, one grid of blue intensity. And so put together, that actually is like a 3D object. If you imagine just like 3 layers of grids of like different intensity values for different colors, for the RGB colors. So that's like one of the most common like tensor data types. And I believe the only tensor data type we deal with in this program. Yeah, so that's why we come back to this stuff later on as well. But also good to know. All right. Lastly, with pandas, sorry, not pandas. Lastly, with NumPy, there are several built-in methods that you can create arrays to play around with. These are particularly useful. So for example, if I want to create just an array of zeros, because sometimes that's useful. We won't see that right now, but later on, sometimes you just need to create like a grid of zeros. Let's just say I want a 2, 3, oops. It has to be like this in a list. So let's just say I want a grid of zeros. That's just a built-in function that we can use. Sometimes instead of zeros, we want to do ones. That's something as well. Or we can do full. NumPy.full is another pretty neat one. So with NumPy.full, it takes in 2 arguments, the shape, which is a list, and then what you want to fill it out with. So let's say I just want like, I don't know, a grid of 7s. That's just something that's good to know that you can do. So you don't have to like manually type out all of these. All right, questions before we move on to pandas? Okay. So with pandas, again, I mentioned at the start that pandas is basically when you need to work with any sort of like table data, like anything that's like, I don't know, that looks like an Excel spreadsheet. That's what you would use pandas for. Getting data in and out of pandas, sometimes you just have some like data files lying around. If you have like Excel files with data that you want to play around with, how you import them into your Jupyter notebook is pandas has a read CSV method. As you can see here, this is actually I hope that this one still works. I think there might be a time where this stopped working, but this used to point to a CSV file online. I hope this works. I think the last time I tried it, it didn't. Let's see. Okay, so that one didn't work. As another example, hold on. Let me just pull something up super quick. And I will also update the data file when we get to, I'll update the data file on the repo as well. Okay. So what I did was I have this CSV saved somewhere, but it used to be the case where this URL pointed directly to a CSV. So you can actually use a web URL. But anyways, I just transferred this on my computer, and this data set is called auto-mpg.csv. I know this actually, if you look over here, I just dragged it into my desktop, and this is the file that we're going to open up. If I have this data file there, if there are some null values, there are a bunch of different arguments that you can use in read CSV. If you have null values and you want to fill them in with something, like something else. So here I'm just going to fill any null value with a question mark. I can do that there. So I run that. And then by doing that, you can take a look. Oh, DF, which stands for data frame, is one of the more common abbreviations of, or like variable names for a data frame, or like, yeah, pandas. Yeah. So here, I have my data frame over here. All my data is imported. I can start cleaning the data, maybe on a graph some of this data, but read CSV does that. Sometimes you make a new data frame and you want to save it. This is actually pretty neat to know. Let's just say and we'll talk about filtering later. So let's just say I only want to keep miles per gallon and cylinders and mini car. Yeah. So let's just say I have this smaller data frame of mini car DF, and I want to save this because maybe like I don't need all the other columns. I don't want to like take up space on my computer. I just want to save these 2 columns. You can save data frames as CSV files. And CSV, I learned way too late in life that CSV stands for comma separated values. Is just the way that they save the information. So if I want to save a data frame to a CSV file on my computer, I can do this. I call the data frame, use the method toCSV, give it some file name, index equals to false. That's something you all can play around with. But once I run this, you can see that on my desktop, it actually created this brand new CSV seconds ago. And if I just click this and open it up here, it's not going to look super nice, but you can see that it actually saved like my miles per gallon and cylinders. Particularly useful if you're working over multiple notebooks and you want to use the same data file, you can like export your CSV and then just re-import it in another notebook. That's something that you can do too. Just stuff that's good to know, especially coming up with your project. All right. Other things that you can do with pandas, you can actually take other data types and turn them into pandas data frames. Pandas, as you can see, it renders really nicely. Like it's slightly interactive. It's easy to read, much easier to read than like a dictionary or like a super long list. So pandas are therefore very, very likened data types. They're just easier to do analysis with. So sometimes if you have other data types, you can coerce them into pandas data frames. So as an example, I have like a list and a dictionary here. And let's just say I want to turn this into a data frame. Maybe I just want to keep track of like, I don't know, numbers. Pandas has some pretty neat built-in functions that can read other data types. One of them is from dict, where I can use pandas.dataframe from dict, pass it in a dictionary, and then this will tell it how to orient the table. Like, do I want it to be a long table or a wide table? So whether the keys are going to be the columns or the index. So here I want the keys to be the index. So it looks like this. I forget if, I think this is, if I do columns, oops, is it not columns? I forget what the exact one is. Let's find out. PD from dictionary. Let's see. Oh, orient equals columns or index. Okay. So orient equals columns. I might have done something else wrong, but I don't remember. Okay, I think it needs to have like just more. It needs to have just more data for that to work. But anyways, let's leave it as index first. So that just goes to show that you can turn a dictionary into a data frame. Cool. So when you turn a dictionary into a data frame, it doesn't really know what to name this column. So you can actually just update that as well. So let's just say I want to call this column numerical. This is how I would do it. I would just say dot columns. So numbers, which is this new data frame I made, dot columns equals numerical. So there, that's updated. As you can see here, I also have this list of the numbers in Spanish. If I wanted to add a new column, it's actually a very, very similar syntax as updating a dictionary. So here I have the data frame, the new column name, and then the values for the column. So if I rerun this again, you can see that I have my Spanish numbers there. That's just one way of updating a data frame, very similar to updating a dictionary. All right, down here, I've just listed some of the more important or more commonly used Pandas functions and attributes. I'm also going to talk about what is the difference between an attribute and a function. One thing that people always ask me is like, how do you know when to put the parentheses at the end versus when not to put a parentheses at the end? So we'll talk about that. Here, what I'm doing is I'm just loading a built-in data set. Something that you'll see in some of the study groups and some of the labs is some libraries actually have just data sets lying around in the library that you can just use. So this is a library that we'll be using later. It's called scikit-learn. And they just have a lot of different data sets. And this is just the syntax to load this wine data set. So when I run this, and let's actually take a look and see what this one looks like. This is a data set about wine. I'm guessing alcohol level, I don't know, the different chemical components of wine. And this is what that data set is. And we're just going to mess around with this data set. I wouldn't worry about this part for now, if that doesn't make sense. We just need some data to play around with. So let's just talk about attributes versus methods. So attributes, I like to think of it as characteristics where no computation has to be done. And whenever something is an attribute, you don't need to have the parentheses at the end versus a method. And a method, usually you have to compute something and therefore an empty set of parentheses, or sometimes there are arguments in the parentheses. That's the main difference between attribute and method. Usually if you're not sure which one is an attribute or a method, trial and error will tell you. So let's just try some of these out. So I saved that data frame under the variable name df. So let's just do df.index. df.index will give you all the indices of the data frame. And this column here with the bold numbers is the index. So here you can see that it's a range index that ranges from 0 to 178. If I, let's say, forgot that it was an attribute and I try and do that, you get some sort of error. And then usually, you know, all right, let's just try it without the parentheses, see if that works. Coding is a lot of trial and error. Another attribute is columns. Columns just gives you all the column names. Very similar to, like, for a dictionary, how I would do .keys to explore. Sometimes data frames can have a lot of columns. I have students who are working with like hundreds and thousands of columns. So sometimes doing a .columns where you can read it like this, instead of having to scroll and read the column names like that, might be a little bit more helpful. df.dtypes is a really neat one as well. Here you can see that all of the values here are numbers. And so if you had different data types, because you can have different data types, I think if you take a look at this car one, I have some words, some integers, some floats. If I do car df.dtypes, it will give me a combination of floats, integers, and object. One really quick thing to mention is that in a data frame, a string is an object. So this car name was strings, and it just comes up as an object. Object is just the name for strings in a data frame. And then very similar to what we had as with arrays, you use .shape. And .shape will show you the dimensions of your data frame. So there's 178 rows, 13 columns. I honestly always mess the rows and columns order up, but yeah. So these are attributes. Basically, attributes is something that like no computation has to be done. It's something that is usually already stored. The information is already there when the data frame is created. So it's more of an attribute versus a method. When a method is something that they have to like do some computation to give you a result. So let's take a look at some methods. And we're just going to work out the same data frame. .head and .tail are the most common ones to just inspect your data frame. If you just want to see like a couple rows, you can use .head, .tail. So .head, and it's kind of computation because .head actually is filtering out the first 5 rows of your data frame by default. By default, it takes 5. dot head does that. If you want to take more, you can actually pass in a number. Dot head 20 gives you 20. Dot tail does a similar thing, but instead of taking the first however many, it takes the bottom. So here it's giving me the last 20 rows. If I don't put 20, the default is 5. How do you know what the default is? If you look at Pandas df head, for example, it usually tells you in the documentation what the default is. So here, parameters, and the default is 5. And so if you're not sure what the default is, look at the documentation. So that's dot head and dot tail. Other pretty neat ones are dot info. I like to use dot info and actually I like to use all of these. But dot info will basically tell you like an overview of your data frame. So what are the columns, how many non-null objects there are, or non-null values there are. So if you see that, I don't know, so it says here that there's 178 entries. If any of these numbers are under 178, you know that there are some missing values. And then the float, the data type of it, and these are all floats. Dot info is one of them. Dot describe is another pretty neat one. Dot describe gives you like the overview statistics of every column. So you can see these were all the columns that we had in the data frame. It gives you how many values there are, mean, standard deviation. This is a good one to help check for like, are there any outliers? And then we'll get to more of that when we get more acquainted with pandas. Another pretty neat one is .na.sum. You can also stack methods. So if you want to do like a bunch of different methods all at once, you can actually just keep stacking them. So as an example, is NA, what it does is it actually broadcasts whether a value is a null value or not. So after doing this broadcasting, it turns all of the values into true falses, depending on whether they are null or not null. And so all of these are not null. As we saw, there are no null values in this data frame, no missing values. We can stack methods, and I like to do .sum. What's pretty neat about Boolean values can also be interpreted numerically. So true is 1, false is 0. What I can do here is I can do .sum. And by doing .sum, it sums all the true false values per column. And so you can see here, because they were all falses, all of them end up being 0. I wonder if the car df has any. I don't think it has null values because I did that fill null values, but yeah, okay. If you ever did this and there were null values, you would see some numbers show up here. So to show that we can stack even more methods, let's say I just want to find the total number of null values in this entire data frame. I can do another .sum, which is pretty neat. And then it'll just come out as 0 because there are none. So if there were more things to do, you can do that. So let's say we have is NA. We can do a mean as well. I mean, there's not much to do here with the .mean, but actually let's do df.mean. df.mean gives me like the average of each column, and I can stack methods. I can do like the sum of all the means if you ever need to do that. So just so you all know, you can definitely put method after method. Okay. Questions so far? I feel like I've like bombarded you all with a lot of like data frame functionalities. All right. The last main thing we're going to talk about here is selecting or subsetting your data frame. And there are actually several ways to do this. There actually have also been newer ways that have come out on how you can subset your data frame. So on Medium, there are a lot of articles talking about like filtering or subsetting a data frame. So if you just look up on Medium, there'll be a lot of things to read about that. But some of the main more, I guess, traditional methods that have existed for a while are iloc and loc. I don't know if it's loc or lock. Some people say iloc, but loc stands for locate, so I say loc. So these are two of the main ways. The I for iloc stands for index. So basically, it's you're locating things based on its index. So if I wanted to get like, let's say this value over here, I want the value from the first row, or like not the 0th, but the first row and the first column. I can do f.iloc 1. Oops, why does that do that? Okay, .iloc 1, 1, and I get that one value. You can also use slicing, same way as you did for a list, same way you can do for an array. Let's just say I want to, I don't know, everything aside from the first one. I just don't want the first row. I don't want the first column. I can do it that way. So iloc allows you to slice it based on numbers. Besides iloc, there's loc. You can do regular locate. Two use cases. You can select it by a label or the index, or with a Boolean or conditional lookup. And I'll talk about both of these. So let's just go back to our original data frame. So let's just say I want to get, I don't know, the alcohol and ash values. One way to do that is, and you have to do it rows, columns. So I would do, let's say I want the alcohol row and the ash row. And then here, because our index is also numbers, we can actually slice the numbers as well. Let's just say I want rows 2, 4, 6. What do I do here? Oops, maybe I can't do double. I'll show you all a way to do that later then. Okay, let's just say I want the alcohol column and then row 2. Sec, this way. Apologies, you guys. Let me just Google this super quick. So very, very normal to always look up documentation. Okay, let's take a look and see how they do it. I like Pandas because they have a lot of examples in their documentation. Okay, so it looks like we got to do it that way first. Okay, so let's just say I want to get the alcohol and the ash columns. I would do it alcohol, comma, ash. And did I spell it wrong? Never mind. Okay, there we go. That's what I was forgetting. Within the .loc, where I got mistaken was loc takes in two arguments. You need the row values and then the column values. So here, basically, just putting a colon tells it to take all rows. And then this is telling it to take these columns. So I think I flipped it the wrong way earlier. That's what I made mistakes. So let's say I want rows 2 through 4. That's how we would do it. Okay. So that's selecting it with a label or with an index, with a column or with an index. So let's say I want rows 2 through 4, columns, alcohol, and ash. Another way to do it is through conditional lookup. And the way you can do this is, let's say I want, actually, let's print the data frame so we can come up with some conditions. Let's say I want all the rows where alcohol is greater than 14. Let's just take a quick look here to see if they have any examples so I don't mess this up again. Okay. All right, so to put a condition, you do it like this. So let's say I want all the rows that have alcohol greater than 14. The way you do that is you say, all right, out of my df from the alcohol column, I want it to be greater than 14. And then these will just return all the rows that have an alcohol value of 14 or greater. So yeah, so this is how you would filter a data frame for a specific condition. You can also stack different conditions. I'm not gonna mess with, let's just try out of curiosity. Let's just say, okay, ash, let's go with like more than 2.5. Yeah, I figured that was what's gonna happen. Yeah, I'm not gonna mess with this. I'm not gonna spend too much time debugging this, but I think maybe I do this. There we go. You have to, if you have multiple conditions, this is actually similar to an or statement. I wonder if this works too. Okay, yeah. So in Pandas, that straight line down is an or. If you want to do like an and, you do an ampersand. And yeah, that's how you just filter with multiple conditions. Cool. Or you can use the filter function. The filter function is one of the new ones I was talking about. The dot filter function actually came out after I did the program, so I actually don't use it too much. But I think it works kind of similar. If you want to filter by a specific column, you do items equals to 1, 3, I guess. So if I do df.filter and I want to get like the alcohol and let's say the ash and what's another short name? Let's see. Let's just go proline. That's how you can do that. So you get the same result in all these different ways. So up to you, depending on what your use case is, what you're more comfortable with, you can mess around and decide for yourself. Cool. So different ways to select and filter data. I think that was the last of the main things I wanted to talk about today. Questions or comments on anything I've shared so far? All right. Just for some context on the rest of this topic. In this phase, there are some other pretty interesting things. A few of them are readings. So all of these are pandas, visualization with pandas. There are some pretty neat readings here about data privacy and ethics, something that I personally am actually pretty interested in as well. And then in this lab here, it introduces this thing called Kaggle. And I think a couple of you have mentioned Kaggle in our one-on-ones, but Kaggle is basically like a data science website that has a lot of things for data scientists. They have a lot of data sets that you can just download and play around with. And they also have competitions where you can, build your best model and compete with other people. But yeah, this just shows you how to onboard yourself onto Kaggle. We're not going to use Kaggle officially as part of the course, but I'm going to introduce some Kaggle things once here and there where I think it's important and relevant. And yeah, there's this housing data set from Kaggle that you can do this mini project on. So in order to do this mini project, I think they'll have you, I forget, but I think they have you get the data from Kaggle. I forget, but yeah. So that is the rest of topic 4. Questions to close out. All right, on Sunday, when we have our study group on Sunday, we're going to talk about using lambdas with our series and data frames. Oh, something really quickly that I forgot to mention as well. A series is that one-dimensional data type of a data frame. So whenever you get like a single column of data, that is actually a series data type. You'll see that in your labs though. We'll talk about some data cleaning techniques and then data visualizations, which as I mentioned, you get into more formally in topic 6, but it's a good starting point if you want to work on the mini project for this one and you don't want to go through all the other stuff first. Yeah, all right, that's all I had to share for today. I'll see you all at one-on-ones or at Sunday study group, but yeah, any final questions to round out?
No, I'm good.
All right. Well, I'll talk to you all again on Sunday or at your one-on-ones. Bye, everybody.
Bye.
Have a good night, guys.